Imagine waking up tomorrow and discovering a handwritten letter from yourself. The date on it reads 2050. Every prediction inside the letter comes true. It sounds like science fiction, yet modern physics suggests time may not be as fixed as we once believed. Scientists have already observed clocks slowing down in space, particles behaving differently at incredible speeds, and strange quantum experiments that challenge our understanding of cause and effect. So here's the question. If time travel is truly possible, why hasn't anyone visited us from the future? The answer takes us through cosmic mysteries, impossible machines, and one experiment that has reignited the world's biggest scientific debate, experiment that reopened the mystery. In 2022, researchers in Australia published a study that immediately caught the attention of physicists around the world. Their work explored whether certain quantum particles could, under specific conditions, behave in ways that resemble traveling backward through time without creating impossible paradoxes. The results didn't prove that humans can build a time machine tomorrow, but they challenged one of science's oldest assumptions, that traveling into the past must always create contradictions. For decades, time travel had been treated as an entertaining idea for movies. Suddenly, respected scientists were discussing it as a real possibility allowed by the laws of physics. But this raises an even bigger question. If time travel isn't forbidden by nature, then what exactly would make it possible? To answer that, we have to rewind nearly 30 years. Hidden cracks in space-time. In the early 1990s, Princeton physicist Richard Gott proposed one of the strangest ideas in modern cosmology. According to some theories, moments after the Big Bang, the rapidly cooling universe may have formed incredibly thin defects in space-time known as cosmic strings. Don't let the name fool you. These aren't ordinary strings. They are believed to be unimaginably dense. A tiny piece could outweigh entire mountain ranges while remaining thinner than an atom. Gott suggested that if two cosmic strings ever rushed past each other at enormous speeds, they could twist space-time so dramatically that they might create a path leading into the past. Imagine drawing two dots on a sheet of paper. Normally, you travel across the page to reach the second dot, but fold the paper until both dots touch, and the journey becomes almost instant. According to this theory, space-time itself could fold in a similar way. The mathematics works surprisingly well. The problem? No one has ever confirmed the existence of a cosmic string, a science fiction idea that inspired real physics. In 1994, Mexican physicist Miguel Alcubierre found inspiration in an unexpected place, Star Trek. Instead of asking how a spaceship could travel faster, a completely different question. What if the spaceship never moved at all? His idea was simple, but revolutionary. Stretch space behind the ship. Compress space in front of it. Rather than breaking Einstein's speed limit, the ship would ride a moving wave of space itself, much like a surfer riding an ocean wave. This concept became known as the Alcubierre Warp Drive. On paper, such a drive could cross enormous distances in a fraction of the time while technically never exceeding the speed of light. It sounded impossible, but surprisingly, Einstein's equations didn't completely rule it out. The biggest obstacle. Every extraordinary idea comes with an extraordinary price. For the Alcubierre drive to work, scientists would need something called negative energy. Unlike ordinary matter, which pulls objects together through gravity, negative energy would push space apart, allowing space-time itself to bend and move. For years, many physicists believed negative energy existed only in theory. Then experiments studying the Casimir effect showed that tiny amounts of negative energy can actually appear under very specific quantum conditions. That was an incredible breakthrough. Unfortunately, the amount we can produce today is unimaginably small. To power even a single warp-drive spacecraft, scientists estimate we would need an amount of exotic energy far beyond anything humanity can currently create. So, does that mean time travel is impossible? Not exactly. Because the surprising truth is, we are already traveling through time every single day. It may sound unbelievable, but every human being has already experienced a tiny form of time travel. At the Large Hadron Collider near Geneva, scientists accelerate subatomic particles to speeds incredibly close to the speed of light. According to Einstein's theory of relativity, as an object moves faster, time slows down for it compared to someone standing still. Scientists have measured this effect countless times. Particles that should disappear almost instantly survive much longer because, from their perspective, time is passing more slowly. They are effectively moving into Earth's future. Humans have experienced this too. Russian cosmonaut Sergei Krikalev spent more than 800 days in space, traveling at nearly 28,000 kilometers per hour aboard space stations. When scientists compared his time with clocks on Earth, They found he had aged slightly less than everyone else, about 0.02 seconds. It may not sound impressive, but it proves something extraordinary. Traveling into the future isn't science fiction. It's already happening. Even the GPS on your phone depends on this principle. Satellites orbit Earth at tremendous speeds, causing their clocks to tick differently from clocks on the ground. Without Einstein's equations correcting these tiny differences every day, GPS navigation would become wildly inaccurate within hours. Time isn't the same everywhere. It depends on how fast you're moving, but traveling into the future is only half the story. The real mystery is traveling backward. Imagine going back in time and preventing your grandparents from ever meeting. If they never met, your parents would never be born. If your parents were never born, neither would you. And if you never existed, who traveled back in time? This famous puzzle is known as the grandfather paradox, and for decades it convinced many scientists that backward time travel must be impossible. However, modern physics offers another possibility. Some quantum models suggest that the universe may naturally prevent paradoxes from occurring. Instead of allowing history to break, events would automatically adjust so that the overall timeline remains consistent. In other words, you might be able to visit the past, but changing it could be impossible. Reality may always find a way to protect itself. Scene 7. Stephen Hawking's famous experiment. If time travel is real, then where are all? 2009, he organized a party for time travelers. There was cake. There were balloons. There was even a welcome sign. But Hawking kept the event completely secret until after it had already ended. Only then did he publish the invitation. If future civilizations could travel through time, they would see the invitation and come back to attend. Nobody arrived. Does that prove time travel is impossible? Not necessarily. Some physicists believe that a time machine might only travel back to the moment it was first activated. If humanity builds one in the year 2100, travelers could visit any point after 2100, but never a time before the machine existed. If that's true, no one from the future can visit us today because the doorway hasn't been built yet. Scene 8. Conclusion. 100 years ago, airplanes sounded impossible. Walking on the moon seemed like fantasy. Today, both are part of history. Time travel may now stand at that same crossroads. Cosmic possible amounts of energy. Quantum physics still raises more questions than answers. Yet, every year scientists learn something new about the strange nature of space and time. Perhaps the greatest mystery isn't whether time travel is possible. Perhaps it's whether humanity will survive long enough to discover how. One day, future generations may look back at our world the way we look back at the age before electricity, a time when people believed certain things could never happen. Until that day, every experiment brings us one step closer to answering one of the greatest questions ever asked. Can humanity truly conquer time? Only the future knows. Thanks for watching. If you enjoyed this journey through science and mystery, don't forget to like, subscribe, and join us for the next incredible documentary.